Here is the product rule and the quotient rule. So today we started out with a do now, and I gave everyone this as f of x, and here's g of x. And I said first FOIL f of x times g of x, and so that's A1 is FOIL it, and 2 is find the derivative. So here, let me FOIL it. It's 6x. I'll wait. 6x squared, and then we have 2x times 2 is 4, plus another 3x is plus, so it's plus 7x, and 2 times 1 is 2, and then I said part 2 is to take the derivative, so I'm just going to put a prime around this, and we know the power rules at this point, so this is 12x plus 7. Okay, that's just straightforward power rules. Bring the power down in front, reduce the power by 1. Okay, so part B was find f. Now I want you to find f prime of x and find g prime of x. So here f prime of x, my stylus is awfully slow. Let me see if I should kill a process. No, I'm just kidding. I'll just suck it up. F prime of x, well, again, here we have 2x plus 1, so f prime of x is 2, and 2, sorry about this. And what is g prime of x? G prime of x is just 3. I'll put it up like that. G prime of x equals 3. And so we ask the question here, is f of x times g of x the derivative of the product? Is that the product of the derivatives? The answer is no, because you can see here that 3 times 2 does not equal 12x plus 7. So that's just saying that the derivative of a product is not the product of derivatives in this case. And it turns out there might be cases where you can get lucky and the product of the derivative is the derivative of the products. But in fact, when you have a product, so in this case we have, right, a product is multiplying two things together, f of x times g of x, you should use the product rule to differentiate. So this is the product rule, and we're going to confirm it in this case. So we found f. If we multiplied them first and then found the derivative, we found it to be 12x plus 7 in this case. And does that equal, first the derivative of f with respect to x, we said that was 2. What is g of x? G of x is just 3x plus 2. And now the next step is to find g prime of x, and that is 3. So we add 3 times f of x. Oops, that's supposed to be a 3. F of x is 2x plus 1. And if you multiply this out, these terms out, 2 times 3 eggs plus another 3 times 2 eggs, that's 6 eggs, plus 6 eggs, that's 12 eggs. I'm skipping some steps just because my pen is so bloody slow. 2 times 2 is 4, plus another 3 times 1 is 7. So we just confirmed the product rule here. So then this smart question right here is, oh, by the way, the product rule is just a tool, okay? It's a tool that we can use to evaluate derivatives when we have a product of functions and we need to find the derivative of that product. It's just a tool, just like a plastic bag is a tool, or a hammer is a tool, or a firecracker is a tool. Like, those are things that we would use to take care of a population of squirrels, maybe. This product rule is a tool we can use to take the derivative of a product of functions. Okay, so next, how can I move this down here? So the smart question is, Mr. Steiner, why do we need the power rule? If I can just FOIL each time and then take the derivative, isn't that fine? Well, here's your answer to that one. When you have a product of polynomials, sure, you want to FOIL something like this before you take the derivative, go ahead. Like, see this If you want to FOIL first and then take the derivative, great. If you want to use the product rule instead, it's easier, faster, and there are fewer pitfalls. As if pitfalls are algebra 1 mistakes. And also, here's the other answer. If you want to if you're asked to take the derivative of sine of x times 4x squared minus 3x minus 1, even if you want to distribute the sine of x, right? So you don't want to use the product rule. You want to distribute this over each of these terms. Okay, you want to distribute the sine x over each of these 3 terms. You would still have to take the product rule because you use the product rule because you have sine of x times 4x squared. So here here's the product rule, and here is also the quotient rule. And this is just a way that some people remember it. Like, just remember SOHCAHTOA. We remember this. This is low d high. So low d high is g of x times f prime of x, right? The low is the g of x. The high is the f prime of x. So d high is the derivative of the high function minus, well, the minus is just that minus sign right there. And that's going to be the killer. That's the one you're going to forget to distribute, but not if you take the negative sign seriously. And that's high d low. So this is the upper function f of x times g prime of x all over low squared and low. So it's low d high minus high d low over low squared. That is the quotient rule. You just have to identify your f of x and g of x before you can use the quotient rule. Okay, do an example, but I'm out of time, and well, I hope that was helpful.